Welcome to section 9. In this section, we are moving beyond core Python and into libraries which expand what Python can do. Python becomes powerful because of its huge ecosystem of libraries such as NumPy for numerical computing, Pandas for data analysis, Matplotlib for data visualization, requests for API calls, Django and Flask for web development, and TensorFlow and PyTorch for artificial intelligence. In this section, we will learn the three most widely used data libraries: NumPy, Pandas, and Matplotlib. These form the foundation of data science, machine learning, and data analytics. Let's begin with NumPy. NumPy stands for Numerical Python. It is used for fast numerical computation, multi-dimensional arrays, mathematical operations, and working with large data sets. Before using any library, we must install it. Open your terminal and type pip install numpy. Now import it at starting of the code using import numpy as np. NumPy introduces a new data structure called an ND array, a powerful, fast, multi-dimensional array. For example, numarray equal to np.array 1, 2, 3, 4, print numarray. A question may arise: why use NumPy arrays when we can use Python lists? The answer to this is that NumPy arrays are faster and more memory efficient than Python lists and would be required for number crunching of large data sets. Let's explore what NumPy arrays can do. We can create a basic array from Python list. We can create an array of zeros by using np.zeros. We can create an array of ones by using np.ones. We can create an array from a range by using np.arange function. Let's have a look on some mathematical operations on array elements. We have an array with 4 elements, 1, 2, 3 and 4. First of all, we use array plus 5. So every element will have 5 added to it and we'll print out the output. Then we multiply every element by 2 and print out the output. Then we raise every element to the power of 2 and print out the output. These operations work on every element automatically and are extremely useful for scientific computing. NumPy handles 2D arrays or matrices easily. For example, m1 equal to npy.array 1, 2, 3, 4. We can access the elements of the matrix by specifying the row and the column index. The index number of the first row and first column are 0 and 0. So when we give a statement print matrix 0, 1, it will print 2, which is the element falling in first row, second column. Let's create another matrix M2 with elements 5, 6, 7, 8 and perform a matrix addition. When we give a statement print M1 plus M2, the elements of the resultant matrix will be printed out. We can also handle matrix multiplication by giving a command M1 dot M2. And when we print it out, it will print out the resultant matrix after multiplying the two matrices. NumPy makes number crunching extremely fast, which is why data scientists love it. Now, let's learn Pandas, the most important library for data analysis. For using Pandas, open the terminal and first install it by typing pip install pandas. Then import it at the starting of the Python script file by typing import pandas as pd. Pandas provides two powerful data structures: series, which is one-dimensional data, and data frame, which is two-dimensional tabular data like Excel. Example of a series: s equal to pd.series 10, 20, 30. Example of data frame: data equal to name and age. Data frames are the heart of modern data analytics. Let's work with real data frame. Here we have a data frame with name, age and marks of 6 students. The df.head function in Pandas returns the first n rows of data frame, used for a quick peek at your data structure and content. By default, it shows the first 5 rows, but we can specify any number. It offers a vital way to inspect data without loading everything. Here we see an example where we are calling the head function with 4 as the argument. So it will show the first 4 rows of the data. We can select a single or multiple columns by giving column names within square brackets. We can filter rows by giving the condition within square brackets. Here we are defining the condition that marks have to be greater than 90. We can sort the rows by specifying the column to sort by within square brackets along with the sort order. Here we are sorting by the marks column and keeping ascending as false. So marks will be listed in descending order with the top marks on the top of the list. Data frame manipulation is essential for real world data. Pandas makes working with CSV files extremely easy. Read CSV function is used for reading from a CSV file. Here we have an example. We are reading from the students.csv file and printing the result. Specific columns can be read using useCalls parameter with the read CSV function. Here we see that we are again reading from the students.csv file with useCalls as name and course. ToCSV function is used for writing to a CSV file. Here we see that we read the 2 columns name and course from the students.csv file into the data frame object df and then use the ToCSV function to write to a new file filtered students.csv. We can open the filtered students.csv file to verify or use the type function on the terminal to view its content. Thousands of companies use Pandas for cleaning and analyzing CSV data. Now let's visualize data using Matplotlib. First of all, install it using pip install matplotlib and then import matplotlib.pyplot as plt. Let us create a simple line plot. Here we have 2 series x and y and we are using the plot function to plot them. plt.show function will bring about the chart on screen. Now we move towards creating a bar chart. We have months and sales figures and plt.bar with month and sales will create a bar chart. Next chart of interest is the pie chart. We are passing the sizes and the labels to the plt.pie function to create a pie chart. Matplotlib is the foundation of Python data visualization. Let's combine our skills of Pandas and Matplotlib for real data visualization. Assume we have a data frame with months and sales figures. Let us plot the sales from this data. Using the plot function, we'll give a title, an X label and a Y label to the chart and show it using the show function. We have learned working like real data analysts. We have got an overview of how data analysis and visualization is done in Python. But data analysis is a broad and extensive topic and needs a dedicated course of its own. I would bring out the well-designed, job-oriented and industry-relevant course on data analysis in Python within a month's time. So stay subscribed and tuned to my channel. Try these exercises. First, create a NumPy array of 10 numbers and print their squares. Second, create a data frame of 5 students and sort by marks. Third, plot a bar chart showing marks of 5 students. Fourth, read a CSV file using pandas and filter rows. Fifth, plot a line chart from CSV data. These exercises make you comfortable with the most important Python libraries. Let's build a practical project, a sales data visualizer. This project will read sales data from a CSV, show highest and lowest sales, and plot monthly sales graph. Here we have the monthly sales data stored in the sales.csv file for the month January to June as displayed on the screen. We read the CSV file using readCSV function into a data frame named df. Then we print the highest and the lowest sale using the data frame max and min functions respectively. The month and sales column of the data frame are passed to the plot function to create a line graph. The marker equal to O parameter is used to display a circle marker at each data point on the plot. The graph is given a title, x-axis label, y-axis label, and the grid display is set to true. This project covers CSV reading, data analysis, and data visualization. Excellent job completing section 9. These are real-world skills used every day in industry.